Going on, guys? We have a question right here. It's asking, determine the force that the jaws of the metal cutters exert on the smooth cable C. So we have a cutter right here. So they are asking to find the force in C. So let's draw this part first. So in order to find this, because we have too many unknowns, so in order to find this, I have to separate it into pieces. So we have to find C. So I separate this piece from this one and draw this here. It's gonna be like this, something like this, and here we have C, and that's what we have to find. So it's going to be FC, and this only has vertical movement, so right, therefore it's going to be vertical force. And here FV, we have an FV right here. Let's say FED, and also we have A right here, so it's going to be AX and AY. So AX is going to be somewhere like this. We don't know the direction, we can just assume, and we will figure it out. So first of all, from this one, we can say that Ax is going to be equal to 0 because this is the only horizontal force right here. So if I take total horizontal force equal to 0 and solve for this one, Ax is going to be equal to 0. So since we got this one right here, we have three unknowns. Let's put the distance first. This is 30 millimeter from here, 30 millimeter, and this is going to be 80 millimeter. 80 millimeter. So let's choose a different color now. Okay, here we go. So first of all, we have three unknown here. So it's really hard to find one of these, right? Because we can't take moment around, or we can't take vertical components because we have three unknowns. So in this case, what I have to do is I can find this AY is sharing with this component right here. So I can take this component and try to figure out AY. So let's see how we can. So I take this part from here and draw this one. It's gonna be something like this. And this is my part right here, and we have this one right here. Also we have F in the middle. This is gonna have two forces, Fy and Fx. Also we have A right here. It's gonna create. So in this case, we have to make sure that the direction we are putting here should be opposite to this one because it's according to the Newton's third law. So every action has opposite and equal reaction, right? So since this AY is acting upside, I have to put it downside here. AY and AX is acting this side, so I have to put other side. So that's how we put the direction. Then we have this distance is also, this is making 15 degree, the vertical 15 degree. Also here we have 100 Newton, and 15 degree, and they have given this distance. This is from here, it's 20 millimeter. So that's all we need to know. And also we have this distance is 400 millimeter. That's all we need to know. So first of all, let's see how we can find AY. That's our purpose, right? And we know AX is equal to 0, so we don't have to worry about this. Then Fx, Fy we unknown. AY is that what we need, and we have others unknown. So to get rid of these two of these unknown, I can use moment around F. So if I take moment around F equal to 0 in statistics, and If I take counterclockwise positive and solve for this one, I will get so since if you see 100 Newton and Ay, it's not perpendicular to this object, so we have to always take the perpendicular components of this object. So if I take that one, it's gonna be, so this is making 20 millimeter is this distance. So if I take the perpendicular for this one, actually this should be straight to this is straight to this one, right? So if I take the perpendicular to this one, actually there's no distance between f and ay, so we can't take that one. But if I take the horizontal of the like other components, so in this case what's going to happen is, if this is 100 Newton, it's going to have, this is the perpendicular, it's going to have a y component and another component like this, so two different components making 90 degree. So ay also gonna have something like that, but ay sine 15 we can't take it because it doesn't have any distance between them. But I can take ay cos 50, I can take it, I can't take it, but ay sine 50 I can take because it's going to be this direction, and we know that it's 20 millimeter, that's going to push this into counterclockwise. So I can take that, so this is going to be counterclockwise mean positive, so it's going to be ay times this 20 millimeter, this distance, this distance. So it's going to be times 20 millimeter, and that's this is a by I have to write it a by sine 15, sine 15 times 20 is equal to this moment, and this 100 Newton is going to make two different moments. It's going to have both of them because it has a horizontal distance and vertical distance. So this, in this case, if I take this one cos 15, it's going to push this object down, so it's going to be clockwise, and it is in 400 millimeter distance, so I have to put minus sign in front of it, and it's going to be 400 times 100 cos 15, 100 cos 15 degree, and it's going to be negative, that's it. Then it's going to be have another component that's sine 15. So if I take 100 sine 15, it's going to be it's going to pull this object counterclockwise, so it's going to be positive, positive, and so since this is okay, if I take sine 15, yeah, it's positive, and it's 20 millimeter, 100 sine 15 times 20 millimeter, and let's make sure we got all the direction right. So this is gonna be like pulling this object counterclockwise, so we got it positive, and this is pushing this object down, so it's going to be clockwise, therefore it's going to be negative, and the sine 15 is going to be pulling this object counterclockwise, therefore it's going to be positive. So we got everything right, is equal to 0, and if you solve for ay, you will get 7364.10 Newton. So this is the value for ay. Since we have got ay, we can directly go to the other picture right here, and let's see how we can figure it out. So we have found 7364.10 Newton, right? So ax is 0, we don't have to worry about that. Ay, we have found it out. FED is unknown, FC is unknown. So I can't take vertical components because two unknown are there. Horizontal components nothing to do with the, nothing can we can do nothing with this horizontal components, but I have to get rid of this FED. So to do that, I can take the moment around E. So this is E, right? So if I take moment around E, what's going to happen is it's 0 in statics, and if I take counterclockwise positive and solve for this one, Fc is going to be pulling this object clockwise, so it's going to be minus Fc times the distance is 30 millimeter, and here we have Ay pushing this object counterclockwise, therefore it's going to be positive Ay times 80 millimeter, and if I solve for this one, it will become Ay. So Ay is known already, I can plug this one here. So if I find Fc comes out to be 19637.60 Newton, so you can say 19.6 kilonewton. So this is my final answer, and that's what they're asking. Determine the force that the jaws of the metal cutter exert on the smooth cable C. So Fc is the question, we have found it out. And that's it. I hope you guys like this video. See you next time.